Hello, everybody. Thank you for joining our web seminar. My name is Rainer Fuchs. I'm an application engineer at IFM Electronic. And today I will show you how easy it is to integrate IOLink into the PLC world. If you have any questions, please post them in the chat. My colleague Daniel will support you and answer any question. Okay, as you can see, we are using Siemens TIA Portal to show how to integrate IOLink, how to use the function blocks, and maybe we can bring the camera to the desk. As you can see, I have here a Siemens PLC and two IFM IOLink master, and in the front there is a little temperature sensor, and we will get all informations which are available from this temperature sensor to our HMI surface, which could also be at your machine, at your plants. And here you can see all advantages of IOLink, and we will bring it here to life with our PLC program and function block. Okay, I will talk a lot about our starter package, where the examples and also the function blocks are hosted. If you are wondering where to find it, this is quite easy. You go to our homepage and then press Industry 4.0, IOLink, system integration, PLC connection, and here you have to select which field bus system you are using. We have a very strong examples for Profinet and also for Ethernet IP. We are on the way to provide examples and function blocks for the Codesus world, and we also have function blocks for Schneider. And if you are using other PLC systems, please let us know. Even if we don't have a complete package, we have a starter package with some small examples, and we will support you also with other systems. I think my colleague Jana will post the chat, this link into the chat, then you can use and download afterwards. These examples and function blocks are tested. Customers use them already, and they are free to download. You don't have to pay any money for it. Just take it, use it, and see the advantage of IFM products and also of IFM function blocks. Okay, then let us start to implement IOLink into TIA. The first thing we have to implement is the IOLink master. IOLink master is a Profinet device which converts the IOLink signal to the field bus, and from the field bus then to your PLC. As you know, devices which are not from Siemens are not implemented in the catalog when you install your TIA application. But that's no big problem. You get the GSDML files for our IOLink masters on our homepage. They are also included in our starter packages. Download them to your hard drive and then go to Options, Manage GSDML files, move there where you have downloaded, where you've stored it, and mark them, and they install. I won't do this yet because I've already done this, and it takes some minutes until the catalog is updated. So I think if you are working with PLCs, you know how to do that. And if you have questions how to do it, please let Daniel know. Okay, if you have installed the GSDML files, you find our IOLink masters on other field bus devices, Profinet IO and again IO, then IFM Electronic, and here you have all IOLink masters from which we provide. Okay, for this example, for this web seminar, I would like to use the AL1100. It is not our best one. All others are the same. The reason why I'm using that is if you are buying a starter kit, IOLink starter kit from IFM Electronic, this IOLink master will be included. And so for me, it makes sense to use this master also for demonstration in this web seminar. You just click it with your mouse and put it here in the TIA surface. Now, you have to connect it with the Profinet. What's that? What's up? Oh, the first surprise today. It worked perfectly this morning. Now Tia is telling me that I have no Profinet available. But here it is. Oh yeah, that's Tia. Everywhere surprises. Just give me a second. Yeah, that's always. If you want to show something, it always goes wrong, even if it works perfectly this morning. So now let me see why is there no Profinet controller available? I don't want to delete it because I also have my panel here. And if I delete it, if somebody has an idea, please write it to the chat. What? Been offline. That's ridiculous. Why? Okay. Thank you very much for this hint. Yeah, it's not the best idea just to disconnect the laptop and go to the next room and then come back and plug it in again. And yeah, okay. I don't know who gave that hint, but if you visit IFM at a fair, please go to my colleagues and say, I owe a beer, you owe me a beer for this perfect hint. Thank you very much. Okay. Also, you have to give the Profinet device a Profinet name. Then you go online, you search for the devices. And you see, I found my IOLink master, and because it's not the first workshop, I have already given it a Profinet name, and so my PLC detects this IOLink master and gives him IP address. Okay. I think for everybody who worked with Profinet, this is nothing new. It's Profinet. It's the same story if you're connecting an IO-Link master or a frequency converter. I think this was not new for you. So let's move to the IO-Link part. As you can see, this IO-Link master has 4 plugs, and the slots for them are empty. You have to configure here in your PLC surrounding how the different plugs should work. You can use an IOLink master also for digital inputs or digital outputs. How is quite easy. You just put here the module for digital input to port 3, and now you can connect normal switching devices here to an IOLink master. Same story with the outputs. Now you can connect, for example, a valve to port 4 of the IOLink master and switch it on and switch it off. If a port is planned to be free, if you are not using it, I would like to ask you to disable it. Because if you disable it, you get no fault messages that the device is missing, and nothing is blinking on the or flashing on the IOLink master, which may confuse the maintenance stuff. So please, if a port is not used, take the module for disabled, put it here, and you have no problems and no questions. Why is there flashing something? Okay, but we want to use IOLink. That's the reason why we are here. An IOLink and sensor, from the point of view of a PLC, is an input. So I go here to IOLink input. And now you see here different modules with different spaces of process data. If you want to know which one to take, please go to our web page and type in the article number of the device you are using. In this case, the temperature sensor 7105. I open it, scroll a little bit down, go to downloads, and here you find the description of the IOLink interface. Most of our devices have this description in 10 languages. Please take the one which is comfortable for you most. Okay, because we are international, I take the English one. I open it, and on the second page, you see the description of the cyclic process data, in this case the temperature of this sensor. And if you count, each bar is for a byte. We need a 4-byte module, 4-byte process data for this sensor. I go back to TIA, and you can see this marked one would be the right one. It's also possible to take a bigger device, but please do not take a smaller one. If I would take 2 bytes or 1 byte in this case, I would not be able to get a communication. I will not get any values on my PLC, and the red LED on the master is flashing permanently. So please take the right amount of bytes or a bigger one. I put it here to my port, and the first thing I have to do is oh, it's not too easy. It was the same story this morning. It's not too easy to work with the mouse on the big screen. Okay, the first thing I have to do is to type in the I/O address. This address where you are expecting this value in your PLC. It's up to you where you put it. In my case, I want to have it on 1220 because I generated a tag with this number, which I will use when I implement the function blocks later. But please remember this number. I will show you later at the function block. Okay, the next we have to do is IOLink special. You have to configure the IOLink communication. Port mode is something you can't change because you took the or I took the module and per drag and drop put it here, and so I selected that I want to use IOLink at this port. The next one is the cycle time. I would like to ask you, leave it on the setting as fast as possible, because in this case, master and device get an agreement which will be the fastest speed that they can exchange data. You can make it slower. If you go to our description, you find here the min cycle time of 3.2 milliseconds. That's the fastest speed this sensor can provide process data. You can make it longer. You can say, for example, 8 milliseconds, but you can't make it faster than 3.2 milliseconds. In my case, and I am always working, so why should I do something which can be done automatically? So I leave it on as fast as possible. Master and device get an agreement, and for me it's fine. Okay, the next one is data storage. Maybe you have joined the web seminar of my colleague Daniel yesterday, and he explained that the settings of an IOLink device can be stored in the IOLink master. And if you have to exchange the device, the IOLink master will bring back the settings to the new device, and your plant is ready to start. If you want to use this function, you have to activate it here. There are two use cases. Backup and restore is when you are still on commissioning and you are changing parameters. And if you are ready with commissioning and you want to freeze every setting in the IOLink master, go to only restore, and then you can be sure that nobody can change the settings. Even if somebody presses the push buttons, the master will recognize it and download the setting you as expert have made and stored in the IOLink master. But for my web seminar, I would like to say I'm still on commissioning and take backup and restore. If you want to use data storage, you have to tell the IOLink master which device is connected. This is done over the vendor ID, which is 310 for IFM, but you don't have to remember this. I will show you. And the device ID. The device ID of the device you are using, you are also able to find here in the description of the IOLink interface. Here you can see vendor ID of IFM is 310 and the device ID of this device is 733. Okay, then I type in 733 and say download this configuration to the PLC. Okay, as you know, this will take a few seconds. Okay, load, but it's not too easy. You see this is the biggest challenge if you are implementing IOLink to a PLC world, to work with your mouse. As I finish, and now we should be ready. I go online, and you see everything is green, everything is fine. Green is always a good sign. And you see it was not much work, it was easy. IOLink in PLC, as I said, is not rocket science. Okay, then I go offline. And if you are using a sensor, especially here, this temperature sensor, the most important value for you is the temperature. The temperature is transferred cyclic to the interface of the sensor. I want to show you some sheets, only 2. I start the presentation. Maybe you have heard about IOLink smart sensor profile so far. Before smart sensor profile, every device manufacturer took his own interfaces, his own structures, how to transfer process data. On the left-hand side, you see 3. But to be honest, IFM has 23 different forms, different styles of transferring process data from the device over the master to the PLC. And also the value which was included inside these structures was different between the manufacturers. We took 3 different pressure sensors, all 0 till 10 bars, and had a look which value are they bringing at 5 bar at the cell. And you can see SIG 5000 took 8767 and the IFM 500. And here a lot of customers complained because it is much work. For every new device, you have to have a look at the interface. If the manufacturer does not provide a function block, you have to do it on your own. And you have also to have a look at which value, at which process value at the cell. It is much work, it's complicated, we don't want that. And here, the IOLink community made an agreement with the smart sensor profile. In the headline, here is the real value. This value multiplied with decimal places, but be careful, 10 power decimal places brings the value in the SI unit. And you have also device status and up to 4 switching point. But to be honest, you don't have to care about that. That's my job. I made function blocks also for this smart sensor profile, which can be used for every device which supports smart sensor profile. And how easy they are to use and how much information you get out this smart sensor profile, I will show you now. First, I have to close the presentation. And yeah, we are back in TIA. This was one problem this morning. I switched from the presentation to TIA, but the customer still saw the presentation. But this time it worked. Okay, then I go to the main function block, add a network, and take the function block for process data smart sensor profile. If you are wondering, how should I know how to use this function block? You get for every IOLink device of IFM an example, just download the startup package, and there you can see which function block to use, how to combine them with each other. Copy that to your own project and you are ready to take off. I had a phone call with a customer. I showed him how to use it. We stopped talking and 10 minutes he phoned me and said, Rainer, everything is running. I got it. Very easy. Thank you very much. And I hope you are the same opinion. Okay, then let's first start reading the temperature. I get the raw value from the sensor, and you can see here the address 1220. This is what I typed in the network configuration. And I have also tags here in data block just to make it faster to show you. I think you don't want to see me here typing. Okay, then I go here to the process data, process value, and the first one is the temperature as a floating point value. You have the same as integer value because some customers prefer integer. Then the IOLink status, which means this is the wellness of the device. Is everything okay? Is maintenance required? Is there a minor or the major fault? You all can see all in the device status, which gives you more information for maintenance, more information how to react inside your program. Then you can configure switching points in your device and transfer up to 4 over the smart sensor profile to your PLC, which means, for example, at 60 degrees, switch on, at 50 degrees, switch off again. Okay. One extra point of the smart sensor profile is that you get signals if you are over limit and under limit of the sensor. This sensor measures up to 150 degrees Celsius. It will not break if you are up to 170 degrees, but it's not measuring with the accuracy you are expecting. And this is what we are telling you with the signal OL, or if you are under the limit, with the signal UL. You know if there is something happening in your plant which this sensor cannot handle, you get the information and you can react in your program. Also, when the sensor is not able to work, for example, one setting is missing, he will tell you. He will tell you here, no data, which means sensor is communicating, but the value should not be used because it's not measuring. There's something in between, maybe because a setting is missing. Okay, then I blow it down to my PLC. Yes. And you see we have 27.1 degrees here inside. My colleague was scared. She afterwards she switched on the air condition here in this room. But I told her, no, that's no problem because this sensor is not for air temperature. It's only for liquids. So it's not 27.1 Celsius here in this room. I'm not sweating. It's fine for me. Okay, but if you compare that with analog interfaces, where you just get one value, you get a lot of more information over IO-Link, which you can use in your PLC and which makes your process safe. If there are any questions, please don't hesitate to ask Daniel. Okay, the next one, which I would also like to ask you to use it, is the simple diagnostic of IO-Link. If you use IO-Link with IFM electronic masters, the master adds a PQE, port qualifier information, to each device. And there you get the information. The process value is valid. It's the right device and no major fault. The communication is active. IO-Link is running. And here a common fault message. When the device is sending up an event, a fault message or a warning, this you get here a SAML alarm. And it's not much work to use that. You get a function block for it. And I would like to ask you to do it because it brings even more safety to your process. Okay, then let's go back to TIA and first to the network configuration. You can see here from 1220 up to 1224. It's not 4, it's 5 bytes. The master automatically adds 1 byte for the PQI diagnostic. And how to use it, let me show you my function block. I just go to the next network, pick up my function block, and say, where's the PQI coming from? And here you can see 1224. And here you get the information, just a moment. Okay, if you are using digital inputs, you are, as we done here, you get here the information, signal on pin 4, signal on pin 2. And if you are using IOLink, you get the information, communication is active, IOLink is active. You get the information, the process value is valid. As I said, the right device and no major fault. And you get the information that the device is sending an event, a diagnostic message to the PLC. Okay, I will it's not too easy. But when I'm ready with this web seminar, I will be able to handle my mouse. Okay, then let's go back to my HMI, and you see the process value is valid, the communication is active, and because I did not delete it, there is still event active from this morning. And you see it's not much work, a few mouse clicks, but it can help you to make your process safe, to react on problems the right way. And so it's an advantage for IOLink, not much more work, but yeah, we also support you with function blocks, and I think it's just click and just clicking, not much work you have to do. Okay, the next one you can see here is parameter setting. Daniel showed yesterday the easiest way to do parameter setting is to use the software IFM Moneo. Then you have no PLC programming. You just go online with your laptop over the PLC to each IOLink device in the field, and you can do the parameter setting. But some customers like to have the settings on the HMI because you don't need a further software. The maintenance man does not have to go to his office to fetch his laptop. He just goes to the machine, to the HMI, and does the setting which are necessary to bring or to optimize your plant. And how easy it is to bring the parameter setting to the HMI and to the PLC if you are using IFM devices and our function blocks, I will show you now. Okay, I go back to Tia, but first let me take some water. Thank you. Okay, I go to the next network, and then I take the function block for read and write parameters. It's always the same function block for each IFM IOLink device, because maybe you have heard the word IODD. IODD is the description, the driver of an IOLink device. Software like Moneo Configure use this IODD to display this device inside the software. And I convert the IODDs so that my PLC understands it. I bring them to a data block, and there you have the interface for the parameters. I will show you. You go here for IF for interface, and you find here the device parameters. Let's take one. In this case, it is the fault behavior of the output 1. And let me see. And here at this tag is where my HMI is connected to. You get everything. You just have to generate the surfaces on the HMI. Unfortunately, we can't do it that for you because they are so different from each manufacturer. So we would like to ask you to do that on your own. But you get an interface where to connect. You get a function block. And I will show you how easy and how fast it is to read and write all parameters. OK. Then I connect here the interface I showed to you, just per drag and drop to my function block. It's not too easy to work here. So connected to my function block. Then I have to tell the function block which port, which device I want to use. This is quite easy. Just type here the Profinet device name. And in this case, it is here. Click. It's 283. Let's go to the hardware, to the network configuration. Click here. Properties and hardware identifier. Here it's 283. You can also type in 283, but I think with a symbol, with a tag, it's much more comfortable. OK, that was wrong. So I go to my function block again. So, and now you have to type in the capture ID for IO-Link. It's minus 90,456. And then, yeah, this is a very strange number, but it was the wish of Siemens to use it for Profinet. OK, then I've connected my sensor to port 1 of the IO-Link master. Here you can select if you want to store the parameters you downloaded from the PLC inside the IO-Link master. Yes, I want to do that. I also want to use the block parameter setting. What's up? So, and you can see here on the HMI 3 buttons and 2 feedbacks. These are just bits in the interface which I connect to my function block now. So here. So first read. Then the button for a write. I go to my laptop screen. I think this is easier. OK, and then one for acknowledge. And you get the feedback that the communication to the device is active and that a fault message occurred. So now I download it. Just a moment. Yes. And I go to here to my HMI again. And you see here the device identification is empty. Now I press the button read. What's up? You have to press the button in the simulation sometimes more times because I don't know what is happening there. But you can see I wrote all identification parameters out of the device. I can also give the device a name and write it down. And also I can do all parameters, the setting of all parameters here. For example, the switching point 1 will go active if we reach 60 degrees and go off if we are under 50 degrees. But when I change the setting of the output, now it's normally open. If I change this to normally close and download this setting, here this output should go active. Okay, I write the parameters down. And you see the field is green now, which means I have changed inside the device the behavior of the switching point 1 and downloaded that over my PLC, over my function block in the device, and now it's working as I want to have it without pressing push buttons or taking the software Moneo Configure or each other software. I've just done everything inside my PLC. And as you can see, it took me inclusive talking, I think 5 minutes. And if I would not talk, it would be 2 minutes to bring every parameter of an IO-Link device inside my PLC world. If you want to do the same, please download our startup package. There you find every function block, every information you need. And if there are still questions, please don't hesitate to contact me. Okay, the next one, which I want to show you, are the system commands. I think the most famous system command is go to factory setting. But you have here a parameter for high temperature and also one for low temperature. And here with the systems commandos, you can reset them. And how to work with the system commands, now I want to show you. You also get a function block for it. You just put it here, give it a data block, and you have also here in my, you get also here a UDT with all commands this device provides. And if we go to the first one, this morning, unfortunately, I saw this is German, but here the first one is go to factory settings. In the examples, you will find the whole documentation in English. Okay, and if you want to do or to activate the system command factory settings, you just put this bit in your interface to high, and everything else is done by the function block. But let me show you. I connect this system command interface to my function block. Okay, and here the hardware address. Okay, and now we come to the capture ID. If somebody remembers the right value for the IO-Link masters, please write it to the chat, and the first one will get a free drink on one of our next fairs. Okay, then I first go to the board. This is 1. And also I need some signals here, a reset, and busy that it's active, fault that a fault message occurred. For example, you are downloading a system command and the state of the sensor is that he can't execute this command, then you get here a message. And also here the state, that's the wrong one, here, the status and also the IO-Link device status. So now I type in the capture ID, okay, and download it. Okay, so now the high value at this sensor at the moment is 28 degrees. If I press reset, it should go to around 27 degrees. Okay, then reset high and read it again. And you have seen, you can see here it changed to 27 degrees. And so you can execute all system commands. System commands are also often used if you have to teach something. For example, you have a flow sensor, you say, this is snow flow, and then you switch after pump. This is high flow, and to set these two set points, you can also do over the system commands with two buttons on your HMI, which will make the life for your operators much more easy. Okay, then what is still left here is here the events. You see here you get a common event. And if this common event comes up, the easiest way is go online with Moneo device and see what's happening exactly. But it can also be an advantage if you get this information inside your PLC, because you can generate a fault message on the HMI and you can react on it. Maybe a level sensor has lost his probe. In this case, it's not a good idea to fill in the tank again. And if you know that the probe is lost, you can say, you can bring a fault message, level sensor has lost its probe, the maintenance man knows how to do, not to get to the storage and fetch a new device, but go inside the tank searching for the probe and connect it the right way. And how to get on these events, yeah, that in the past that was a little bit tricky. Because to get this out of the field bus diagnostic works perfectly at Profinet, but on other field buses, it's not too easy until impossible. And so we said, okay, but we want to support our customers to get the events. And we made a normal parameter where we mirror the fault messages. And a normal parameter can be read with each field bus, with each PLC. And how to do that? Let me show you the function block. Okay, I go back to TIA. Take the function block to get the events. Give them a data block. Get the hardware ID, the capture ID, the port number. And with this input, you can select when this this function block shall be triggered to get or to read the information. I have here just a button to show, because then it's easier to show. So, and you get for the events also a UDT, which is fitting to the event to the device you are using. Just copy it from the example and use it in your program. Okay, then I go back. And you see here, these are the events which are provided from this temperature sensor. And then I start reading, and you see I have here an active event, and it's the test event 1. This is something I forgot this morning to reset it. Test events, yeah, are a very clever function. If you want to test if it's working, if you are getting events, there are a lot of devices where creating events is quite difficult. For example, for this temperature sensor, you need a hammer. You destroy it, and then you get the event that you have a device hardware fault. Yeah, but I think your boss will not be very happy if you tell him, oh yeah, event is working fine, but we have to buy a new device. To give the PLC experts a way to test it, you have here system commandos for test devices. This morning I pressed come, test event 1 should come. Now I press go again. Stop. Oh, that's TIA. These buttons are in the simulation not always working. And you press go, and then it should go again. And so you can test your events. Are they coming up? Which means, okay, I have now here, I activated this test event, and now I can deactivate it. Let's test this one and read the events. And now you can see test event 1, 2 is active. I will deactivate it again for my next workshop. And you see the active events, the common message has gone off. I read it again. And so I have no events anymore. Okay, I hope I was able to convince you that IOLink, to implement IOLink in the PLC world, is not rocket science. It's easy, it's just doing, it's not a big challenge. As I said, we provide you function blocks, we provide you with examples. It would be a big honor for us if you would use it in your machines, in your plants. You would not be the first one. You are not a customer for testing. A lot of customers are already using them to get IOLink fast inside the machines with less effort. And yeah, they are happy with it. And I get a lot of positive feedback. Okay, at this point, I would like to say thank you. Thank you for your time. Thank you for joining this web seminar. It was a pleasure for us. If there are any questions afterwards, please write them in the chat, write us emails. We are happy to support you. Thank you very much, and stay healthy, and goodbye.